Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're solving single linear inequalities where the x coefficient is positive. So let's start with some skill I really need you good at for this particular video. I need you super good at being able to solve linear equations because solving linear inequalities is almost identical. Pause the video, double check you can answer the following 3 questions. Okay, you should have got the following answers for those 3 questions. If you're looking at that and thinking, I have no idea what's going on there, you must go back to your building blocks on linear inequalities in order to proceed with this video. And we use the technique of balance. We're trying to isolate x or find x, so we undo the process that happened to x, or we do the same thing to both sides to find out what the value of x is. We're going to do a similar thing when we're solving linear inequalities. Now, just to lead into what they are, I want to ask you a question. Are the following 3 statements the same? X equals 5, and this one, and this one. Pause the video and tell me if they're the same, and if not, why they're different. Well, let me try and draw them. X equals 5 means the number 5. There is only one answer for that. X is equal to 5. Right? That is part 1. There is only one answer for that. Now, x less than 5 means loads of numbers. In fact, infinitely many numbers are less than 5. And we draw it with a picture. We identify 5 as a key point, but we just draw a line to the left of it to say we want all the numbers to the left of 5. So all the numbers smaller than 5. There are infinitely many. And this one here, x is less than or equal to 5. Well, again, 5 is our key number, but we are allowed to colour it in because it's all the numbers x that are either equal to 5 or less than 5. So that's how we draw that picture there. Now, just to be clear why they're different, that there has a single answer for x, that has infinitely many answers for x, that also has infinitely many answers of x, but also includes the value 5. In a similar way, I want you to think about this. Do these 3 questions mean the same? They look awful similar. Well, no. When we solve this, this is a linear equation. Okay, this is an equation because it has an equal sign. When we solve that, we're going to get one answer for x. This, however, is a linear inequality because it's got a less than sign. And we're going to get loads of answers for x. We're going to get a range of answers for x using an inequality sign, and the same here. So we're going to solve these, like things like this and this, in this particular video, and we're going to use very similar techniques to how we solve that. We just got to remember to use the correct symbols as we go through. So let's do a question. Solve the following. You do exactly what you would do in the case where you would be solving 2x add 1 equals 5. Just as you go down the page, you will never use an equal sign, you're going to use this less than sign. So what you're going to do is you'll subtract 1 off both sides. We're trying to work out the value of x, get x by itself, and therefore you'd have 2x is not equal to 4, is less than 4, and then you would divide both sides by 2, and therefore you would get x is not equal to 2, x is less than 2. And remember what that means. That means there are infinitely many values there. If that is 0 there, and this point here is, say, 2, it's loads of values, isn't it? It's all these values here. Infinitely many values of x that can be less than 2. Right? So in this case here, we would have got x equals 2. Here, don't make a mistake. What students do is they just put an equal sign in. Keep your inequality sign as you go through, but you apply the same techniques. Okay, let's have a go at another one. Pause the video, have a go. We want to find the solutions for x, so we want all the x's on the left hand side together, and we want everything else on the right hand side. So we're going to use the balance method. We're saying there's more x's here, so let me subtract this 2x off both sides. I don't want that add 3 there, so let me subtract 3 off both sides there. And let me write down what I get, remembering to keep your inequality sign there. So we would get 4x subtract 2x is 2x, 3 subtract 3, I purposely picked that to remove that. Now it's not equal to, is bigger than or equal to, 2x take away 2x is nothing, purposely picked that. 17 subtract 3 is equal to 14. Now we want to find x, so we're going to divide both sides by 2, and we'd get ourselves that x is therefore bigger than or equal to 7. And on a number line, you know what this would look like. Imagine this was 0 here, and this was 7. It is bigger than or equal to 7, so we'd colour in that line and we draw our arrow that way, and we'd be done. Next one. Pause the video, have a go. Okay, what I would do is I would expand that bracket first of all. That's my first inclination. So keep everything on the left the same. 2x subtract 3 is less than or equal to 5x add 20. 5 multiplied by x, 5x, 5 multiplied by 4 is positive 20. Now what I tend to do in this case, because I see more positive x's on the right hand side, I'm going to rewrite the inequality with the 5x add 20 on this side, obviously the 2x subtract 3 on that side, and just think about it. I want the bigger part with the 5. I'm going to say it's bigger than or equal to that. I've just rewritten this. Rather than write it from left to right, I've written it basically going that way. What that is, the inequality sign bigger than or equal to, and 2x subtract 3 on this side. I've just kind of swapped the roles there. Okay, but I did have to swap the way the inequality worked as well in order to keep the same inequality going, because these two things mean the same. If I had written 5x add 20 on that side and kept the same sign there, 2x subtract 3, I'd have been changing the question. So I'm preserving the same question by keeping the inequality sign the right way. Because I've got more x's over here now, I'm going to use the balance method to isolate x on the left hand side. I'm going to subtract 2x off both sides. I'm also going to subtract this 20 off both sides, and I'm going to tidy it up and see what I get. Well, 5x subtract 2x is going to equal to 3x, and then 20 take away 20 is nothing. It's bigger than or equal to 2x subtract 2x is nothing. Negative 3 take away another 20 is negative 23. And then I'm going to divide both sides by 3. And I'm going to get myself, therefore, the answer x bigger than or equal to negative 23 over 3. And maybe they might ask you to write that as a mixed number. Maybe they don't. It doesn't matter. X bigger than or equal to 3 goes into 23 7 times. Remainder 2/3, so I'd have negative 7 and 2/3, and we're done. Okay, one more for you to try. Pause the video and have a go at this. Same as before, other than we're asked to show the solution on the number line afterwards. So I'm trying to solve 5x subtract 1 is strictly bigger than x add 7. Let's get all the x's on the left hand side. Let me subtract x from both sides here, subtract 1x that is. Let me add 1 to both sides to remove that subtract 1, and let's tidy up and see what we get. Well, what are we going to get? On this side we're going to get 4x, and on this side we're going to get is bigger than 8. And then we're going to divide both sides by 4, and we're therefore going to get x strictly bigger than 2. Showing that on a number line, you're allowed to just do a little sketch here. Let's mark off the point 0, let's say. Let's mark off the point 1. Let's mark off the point 2. Why not do 3 just to give an indication? And just draw a circle over 2. You don't colour it in because it's strictly bigger than 2, but you draw an arrow to the right because we want all numbers bigger than 2. And there we go, we have solved this question. And that's it for this particular skill. Thanks loads for watching.